So here's another example where we have a ball or an object that is being released from the top of a ramp. However, we want to figure out this time the velocity not at the end of the ramp where the level h or level 0 or height is equivalent to 0, but instead at a point that is halfway the height of the ramp. So same procedure where we have to identify information about the initial and final. So our initial height is equivalent to 0.5 meters, while our initial velocity is set at 0 meters per second. So there's no movement. While our final condition where we have h final, this time it's not 0, so that's 0.25 meters, while we want to figure out the final velocity. Okay. So final velocity. Let's proceed with the initial part. Again, total energy, which is the same as the total energy in your final condition because it's conserved, is equivalent to potential energy initial plus kinetic energy initial. Let us identify, let's figure out the potential energy initial. PEI is equivalent to mg times height. And our height is equivalent to 0.5 meters. So therefore, we can say that a potential energy is 0.5 m times g. While the kinetic energy initial is 1/2 mvi, which is 0 squared. So we have to add these two together, which is equivalent to 0. Now we have a value that is equivalent to 0.5 meters, or mg, which is mass times the acceleration due to gravity. That is your total energy in the initial state. Final state, we have total energy, which is also equal to the starting value, which is equivalent to potential energy final plus kinetic energy final. So our potential energy final is simply mg times 0.25, or that is 0.25 mg, plus our kinetic energy. This time it's not going to be 0, so that will be 1/2 mv f. So we want to find the value of mvf. So if you add these two together, our total energy is equivalent to 0.25 mg plus 1/2 mvf squared. So let's equate those two together. So TE on the left side is equivalent to TE on the right side. So what is our TE on the left side? That is 0.5 mg, which is also equivalent to 0.25 mg, plus 1/2 mvf squared. All we have to do is subtract both sides by 0.25 mg. On this side, this will be cancelled. So now we have 0.25 mg, which is equivalent to 1/2 mvf squared. So let us multiply both sides of the equation by m, or let's divide it by m. So let's divide both sides by m, and at the same time, to get rid of 2, let us multiply it by 2. 2 cancels on the right side, m cancels on the right side. So all we have here is basically 2 times 0.25, so this will give us 0.5, m cancels, so 0.5 g is equivalent to v sub f square root. The value of g is 10, So that's 10 equivalent to v sub f squared. So this will give us half of 10, which is 5, equivalent to v sub f squared. Take the square root of both sides of the equation. So therefore, I have my v sub f square root of 5, and that will be the velocity at the final point. And that is 2.24 meter per second. So this will be the speed at the bottom part of our ramp.